Hey, this is just a quick note about our sponsor, Privado, the premier enterprise privacy platform, purpose-built to bridge the gap between privacy and engineering. Its privacy code scanning solution embeds privacy compliance and governance into the product development lifecycle and empowers privacy and security teams with unparalleled visibility of sensitive data flows and the insights to find and fix privacy vulnerabilities. You can leverage Privado's data flows, dynamic data mapping, privacy assessment automation, and real-time visibility of privacy issues. Enter the era of proactive privacy and transform privacy from business blocker to business enabler. To learn more, go to privado.ai. Hello, I am Deborah J. Farber. Welcome to the Shifting Privacy Left podcast, where we talk about embedding privacy by design and default into the engineering function to prevent privacy harms to humans and to prevent dystopia. Each week, we'll bring you unique discussions with global privacy technologists and innovators working at the bleeding edge of privacy research and emerging technologies, standards, business models, and ecosystems. Today, I'm delighted to welcome my next guest, Katharine Jarmul, principal data scientist at ThoughtWorks and author of the book Data Wrangling with Python and the forthcoming book, Practical Data Privacy, Enhancing Privacy and Security in Data. She's interested in ethical and secure machine learning in real-world production systems and is passionate about automating data workflows and distributed data setups. Welcome, Katharine.
Thanks, Deborah. I'm excited to be here.
Excellent. Well, I know we have a lot to talk about today. In fact, why don't we just start off you telling us a little bit about how you ended up focusing on ethical machine learning and then with a focus on privacy. What motivates your work in this space and what was your career path?
It probably starts way, way back when I was working on my master's undergrad thesis, which was actually basically doing natural language processing on the war in Iraq.
Wow. That's fascinating. Were you working for the military?
No, I was a university student, and I wanted to investigate the difference in reporting between embedded and non-embedded reporters. And for those of you that maybe weren't alive or paying attention to the media landscape at that point in time, the war in Iraq was one of the first wars where officially journalists were deployed embedded in troops. Whereas, of course, you had other war reporters that were kind of, the same way as normal freelance or that traveled there on the budget of their own media agencies and so forth. I wanted to study whether there was statistical differences between these two groups of reporters. And indeed, what I ended up finding out is there was statistical differences between reporters who were fluent in Arabic and those who were not, which was a pretty fun realization. And that probably sparked my initial interest in how do we think about ethics of whatever topic we're thinking about in a data-driven manner. And then for many years, I went and did other things. I was a teacher. I was a data journalist. And then I ended up back in the field of natural language processing. And this ethical question at that point in time had shifted because I rejoined natural language processing around the time that we started shifting to deep learning methods and they started working. So this was, 2011, 2012, and we started having word2vec. And at that point in time, it greatly shifted the way that we build language models. And it also brought up a lot of ethical concerns of these less supervised or completely unsupervised setups, which we see also today with the GPT-3 based models like ChatGPT. And all of these are, shown massive spans of text, much of it collected from the internet, much of it collected maybe without consent. We can maybe debate that later. And we show them to learning algorithms. And we also expand the memory of these models, and the implications from an ethical standpoint become quite large because when they're trained with that much internet text, quite a lot of really awful stuff from the internet ends up in these language models and ends up being able to repeat. So I did some research some years back onward to VEC that kind of started my work in the ethical machine learning space.
Wow. So then how did you get inspired to write a book on practical privacy? Because, that's clearly not centered on machine learning.
Yeah, good question. Yeah. I kind of, so I was in the quote unquote ethical machine learning space, I guess you could say, for a while. And I was intrigued by a lot of the work, by the communities there. But what quickly became apparent to me is that the technology part of the ethical machine learning space is probably the easiest part and the least impactful part. And I don't mean to say it's easy in a sense that it's not really important work that people who are researchers will continue doing, but it's in the sense that the hardest part of ethical machine learning and really of any ethical approach to technology is not falling into a techno-solutionist mindset where we believe that we can solve a societal problem with technology. And I think that some of the amazing work that, for example, Timnit Gebru and others are doing, the DARE research lab that Timnit runs, these researchers were really asking the right questions. I'm pushing it forward from a multidisciplinary point of view. And I asked myself, hey, what's the contribution that I can make? At the same time, obviously, being an NLP researcher or being an NLP engineer, even, you end up seeing quite a lot of what later you realize are private data sets. And I became interested in that part of the question and how it related to the ethical part of the question. There was several really interesting pieces of work, including Cynthia Dwork's work, Fairness Through Awareness. And via those pieces of work, I started wondering to myself and then working on if we can solve the privacy parts of the problem and the consent parts of data collection and so forth, maybe we also have a way to essentially jumpstart the ethical parts of the problem. And maybe that's an area where I can contribute something meaningful.
I'm glad that you're assisting in that area and that you're writing a book on this, because my podcast is called Shifting Privacy Left, right? So the idea is that you're addressing privacy earlier in the product development process and before you ever ship the code, right? And I focused so much on the GRC side for so long and kept going, well, we're just in a compliance paper chase right now, just keeps getting buried in DSARs and data deletion requests and, kind of making sure that the new rights for individuals were being obeyed by organizations, which is important, but kept trying to make the argument in multiple companies that if you just train up your data scientists to use privacy enhancing technologies, you could actually not only prevent some of the unethical problems and the compliance paper chase and minimize your risks, but you could also increase the value and unlock the value of your data. And so, yeah, I'm just really excited you're writing a book on this to help educate more in that space, especially when you say it's one of the easier problems compared to some of the other machine learning challenges. I'm guessing, is it, when you say easy, is it because there is an assurance you can kind of place around the inputs and expect a certain output based on math, or is it something else?
I think for pets and so forth, and I guess it depends on the privacy enhancing technology. So one of the things that I found is it was really hard when I got interested in this to learn about these technologies. Most of the media that was available was research papers, and it was really starting from a research level and research point of view, which I strongly encourage and is great. But one of the reasons of writing the book is that it's a fairly steep learning curve. But once you have the basic building blocks, it's quite easy if you already have a data scientist brain to kind of see where they fit and to think through, okay, if we can do this mathematically, it will fit with these types of models or systems or analysis I'm trying to do. And I think that it goes, most of the basis of pets, as you already know, is around math and statistical knowledge, which of course a lot of data scientists have already honed and focused on for most of their career. So it ends up, I think, quite lending the communities lend themselves to each other in a really nice, supportive way. And I don't think it's always easy. I guess what I think is maybe it's an easy step in comparison to questioning what is right or wrong, or what is the moral implications of machine learning in our world, which of course is like a huge, really difficult question that as a technologist, I can answer as a person, but as a technologist, I don't really have the right skill set there to answer or address that question. What I do have is a skill set where if there are smaller, more actionable parts of the problem and the addressing of those issues is led by a multidisciplinary team of experts whose expertise range wide beyond what my skills are, then I can help by being the one that knows how to do the math or knows how to implement this or that cryptographic, or how to leverage this or that cryptographic method. If I can be that person, then I can contribute in a meaningful way. And I think to me, that seems easier. Of course, probably if you're not skilled in math and statistics, maybe other parts of the problem look easier. It's always
that makes sense.
easier to look at other people's problems like, oh, that seems really hard. But this one I can do. So,
right.
Yeah.
So who is the intended audience for the book, and what do you hope readers will come away learning?
So I wrote the book primarily with a focus for data scientists, because again, they have this nice skill set that I think makes it a little bit faster for them to learn some of these fundamental or foundational aspects of privacy enhancing technologies. But I've gotten some feedback. So I'm at ThoughtWorks, which means I have a wide network now of technologists. And I had some internal reading groups and feedback from internal folks. And interestingly enough, there was a lot of people from like QA and software and heads of technology that wanted to read it. And I was a bit concerned. I was like, well, you're not really the target audience. I don't know if it will all make sense to you. But actually, I got some overwhelming feedback from those folks that they learned something. They didn't like going through all the math sections, but they did like kind of the overall, as you know, I mean, privacy engineering is as much about figuring out how to architect it into a system, figuring out how to govern it, as it is about understanding the mathematics behind differential privacy or encrypted computation. And so I think that there's a little bit blips for everyone, but the people who I wrote it for are data scientists.
That makes sense. I think it's essential to know your audience. Even in this podcast, I've chosen to make it pretty technical content, but I think anyone could pick it up and learn something interesting. It's just a matter of willingness and whether or not you have the curiosity to kind of delve into that world.
Yeah, I think having a podcast like this is so great, because it's like I said, when I started my journey, it was like, want to watch this 5-hour video of a conference on privacy enhancing technologies? And I was like, not really, but if it's the only way, I'll do it.
Right.
It's like really nice that there's highly technical, but still to an accessible audience material, right? Because there's a lot of technologists who really care about privacy.
Yeah, I agree. And I think there's definitely a thirst amongst privacy engineers and the community at large for more knowledge sharing and more content and more upskilling. And, there's some people who are just kind of transitioned into a role of quote unquote privacy engineer. And it means something different to different companies that are hiring for that title. So as that world is shaking out to kind of figure out what does a privacy engineer do within business, and what are the overlapping skill sets and such, I'm hoping to be a small part of helping out there, and by bringing on guests such as you who are can go deep into their area of expertise and then help surface it through questions and meeting people where they're at to better understand one concept at a time. So I'm having the time of my life. And I think by the end of this, I'll convince you to start your own podcast. So, okay. You have said ethical machine learning a few times. In fact, I included that in your intro. And I just want you to define what ethical machine learning means to you. What areas must be addressed for machine learning to be considered ethical?
Stay with us. We'll be right back.
Hello, loyal listeners. The Shifting Privacy Left podcast is seeking sponsors who want to help educate our growing community of privacy engineers. Position your brand in front of privacy engineers, architects, developers, researchers, and privacy tech buyers. Insert a 30 to 60 second ad like this one into every published episode of the podcast. This is dynamic content after all. Feature your new product, an upcoming conference, a sponsored special deal, endless opportunities. Email sponsorship@shiftingprivacyleft.com for more information on our sponsorship package. Okay, let's get back to our engaging privacy conversation.
I wonder this often to myself, and I don't think I'm the right person to define ethical machine learning. I think I want to point out the work of DARE again, which is Timnit Gebru's research lab. Timnit was one of the researchers who worked at ethical AI at Google and then was fired for criticizing some of Google's practices around large language models and the biases encountered in these large language models, or societal biases. I mean that, not weights and biases, so to speak. And DARE is doing some really amazing work in the space and continue to, I think, be the thought leader in what should we call ethical machine learning. And then there's also the Algorithmic Justice League, which is Joy Bulamwini's work on creating algorithmic justice and what does it mean. And there's also the FAT-ML community, Fairness, Accountability, and Transparency in Machine Learning, which is an amazing research community meeting yearly. And I think now also hosting workshops pretty regularly at NeurIPS and some of the other large machine learning conferences. And most of these, though, are a quite technical point of view. I mean, some are more multidisciplinary, but they're also technical points of view. But I think there's a broadening area of research in looking at legal intersections of ethical machine learning. So how we legally start to define ethics, as well as I've met quite a few artists and philosophers working in AI in recent years. And I think the conversation is now happening in multiple areas of expertise and in multiple locations. And it must be said too that, a lot of machine learning is being defined mainly in the global north, and the impact that it then has on the global south and on data sets emerging from the global south is also a huge thing that needs to be more hotly debated than it currently is right now. And I think that can easily also be shown with the treatment of workers and Kate Crawford's work on anatomy of an AI and looking through folks in Kenya paid $2 a day or, to train ChatGPT-3 and so forth. And so I think there's so many aspects we can look at, from what does it mean to create an AI system and how can we make the workers' rights more evenly distributed and the remuneration more evenly distributed of that work, and that people know how these things are actually collected and trained, to how they're deployed and how the model themselves behave. But then also, what are the after effects of the deployment of these systems? So the idea and the work in Data and Society and some of Dana Boyd's work in the space is also looking at what does it mean when these systems are deployed? How do they unequally impact different parts of society? And we can see this very, very clearly when we look at gig workers and the rise of gig work is, maybe the model is fair, but how it impacts, let's say, drivers versus the drivees, the customers, is maybe massively different. And the quality of life impact of these algorithms is also massively different. And so I think it expands so hugely that you can't define it in one sentence, which means, there's really important work from all of those aspects. And a little bit of what I've contributed to and some of what the book talks about is how maybe privacy can help some of these bits become a bit more fair or at least more consensual. And that I think is a pretty important piece of the puzzle.
Absolutely. That was a great answer. Like, I think it helped raise the fact that it's not a simple answer, and that the ethics part goes beyond just the model itself and more around what it takes to get that model created, and then especially with the gig workers and such. So thank you for that. So I know that fairness, accountability, and transparency are core to ethical machine learning, especially in the way that the EU frames it. What's interesting to me there is that those are also three of the goals of ethical privacy. GDPR lists fairness, accountability, and transparency as some of the goals in that regulation as well. So, it almost seems to me that privacy and ethical machine learning therefore has like quite a bit of an overlap. I mean, are you seeing that as well? Or do people kind of talk about trying to meet the bar for fairness, accountability, and transparency across both dimensions, both ethical machine learning as well as privacy within the data science community, or not?
I think that the bridge is starting. I think what's difficult is that privacy has kind of not been the central question of a lot of the ethical machine learning research. And for a lot of the privacy research, it's you take on certain assumptions that the users have been contacted or the data subjects have consented and so forth. But I think what we're seeing happening, or what at least I'm noticing happening, is those conversations are starting to get closer to one another. And regulation like the GDPR and the AI Act in Europe have explicitly put them next to each other, which I think starts to make you say, yeah, transparency. If we're talking about transparency in machine learning, what does it mean? Well, maybe it means providing explanations for our predictions, or maybe it means allowing users the ability to opt out, or maybe it means both, or maybe it means some combination that we haven't thought of yet. And I think that maybe it even means transparency of the core training sources and the consent of those training sources. And all of this starts to bring the two topics much closer to one another. I mean, I think it's really interesting from a fairness aspect, because I wonder to myself, like, how fair is it that if your code was used, for example, to train GitHub's Copilot, and GitHub gets money for the essentially, we won't go into intellectual property rights, but essentially something that you created, where does fairness play into that? Where does privacy play into that? And I think all of this touches a lot on Helen Nissenbaum's work on contextual integrity and trying to think through what is the context of machine learning and these large-scale data collection systems in connection to the way that we do things now. And I think most people haven't really adapted how they interact or post things online to the way that we do machine learning today.
It's fascinating. As a consultant, are you seeing additional trends across like maybe different data science teams when it comes to privacy and new ethical approaches to sharing data? Are they trying to solve for mostly the same needs across one another, or is there a lot of variety?
I mean, I think data sharing is still such a such a ridden with problems part of the way that we do data. In fact, it's one of the reasons why I wanted to join ThoughtWorks. So what I was doing before ThoughtWorks is I was working in the field of encrypted machine learning, where I was working with a team formerly called Dropout Labs, now called K-Privacy, that at the time at least was working on how do we do encrypted deep learning with multiple data owners. And really fun stuff. Learned a lot about crypto.
The other kind of crypto.
Yeah.
The original, the OG
the original
crypto.
Yeah, that's true. That's true. And one of, the problem we were trying to solve is like, why share data? You want to build a machine learning model together. Why share data by shipping data back and forth and just signing a bunch of contracts? Why not share data encrypted and still get the value? And then you can make decisions about who can use the model, model, who can see the model, and so on and so forth. And I think that data sharing, it's like when you look at it today, it's like the technologies that we have are so advanced for how we could share data. And then what's implemented is like from 1998 or something. You're like, why is this the way that we're doing it? And I think personally, what I would love to see in my career is the shift to embrace privacy enhancing technologies in data sharing and to no longer normalize the idea of actually sending data to another company, no matter what contract you have.
You mean not sending it at all or to obfuscate it in some way that's safe?
Yeah, I mean, to either use encrypted computation in areas where it makes sense, where really you only need the result, or to leverage tools like differential privacy, or even to make data products available or something like this for people that you normally share data with and instead share some sort of insights, hopefully with something like differential privacy as part of a protection. And to me, that much more mirrors like the legal language when you read through these data sharing agreements basically is asking for something like this. And I think that the reason why it's not more often deployed is A, not enough knowledge about privacy enhancing technologies, and B, not enough of the legal staff really knowing that these technologies are actually ready to go into production systems. Yes, are they still, some of them still cutting edge? Yes, so to speak, but these are by no means something that can't be supported anymore.
I have a feeling we're going to see we're at the dawn of an explosion of privacy enhancing technology use. The UN just came out with a report maybe this past week. It's research into PETs. I have not read it yet. Have you by any chance?
No.
No, that's okay. I haven't either.
Yeah.
But even seeing the US government has come out with a request for information, I believe, on privacy enhancing technologies. The Rise of Privacy Tech had delivered a paper or response basically to address that perhaps we look a little wider than just PETs and that maybe we expand the category to other privacy tech solutions that could meet the needs of organizations. But I do think there's a lot more movement where governments are investigating privacy enhancing technologies. And in some way, once they come out with these reports, it's almost kind of percolates up the chain to different, it lands on someone's desk in business where they're like, maybe we should look into this. It looks almost like the government is putting a stamp of approval on them in some way. And what are your thoughts on where PETs are going to go in the future in terms of their uptake within organizations in the near future, let's say the next 2 years?
Yeah, I mean, just to even contribute, I know that the Singapore government has already also launched some investigation into PETs and more wide-scale use, as well as the UK government. And so I think I just want to double underline your comment there. I think the amount of attention that it's getting from regulatory agencies and from governments and policymakers is growing definitely with time. So I myself have been working in the area of privacy technology now for 6 years, and just being able to see how much we've shifted, how much it's gone from, oh, wouldn't it be nice if we could run this at scale, to, oh, okay, this is actually something that these companies are already running at scale, or at least running on these types of systems. Maybe this can be more widespread deployed, even just the amount of tools that you can now use to support some of the basic and better techniques like format preserving encryption for pseudonymization or something like this, or also things like differential privacy, although one has to be careful with what you buy there, whether it can fulfill end-to-end privacy guarantees. I think that it's pretty amazing to see how it's happening. And I had a chance as part of the book to talk a lot with Damien Desfontaines, who is one of the core researchers at Tumult Labs, who worked with the US Census on deploying the differentially private US Census. And it's just really cool that this stuff is actually already happening. So at large scale technology companies, at many of the FANGs, at some of the cloud providers, and also even at places like the US government, these are already being used at scale. And yes, it's an investment. It's not something, set it up and forget it, but it's an investment that people are actively making. And I think that's really a testament to where the field has gone and the fact that it's out of the research lab now and it's into production systems.
Makes sense to me. So tell us, what are some of your favorite privacy enhancing technologies?
Oh, that's a very difficult
What's
question.
your pet?
Do you have a pet?
I'm not sure if it's necessarily considered a pet, but I am really excited about self-sovereign identity. So that's one that I dive into a lot. I haven't actually done a podcast on it yet, but that one is one of the ones that really excites me about the future, mostly because if we could get enough companies to implement the protocols and standards and such, that effectuate self-sovereign identity and create that ecosystem, which is going to take time. So this would take about 10, 15, 20 years. But if we could do that, I do believe that like 99% of the privacy problems we have today would go away, given that individuals would be more in control of how their data is used or not, or be able to revoke it, or you have all these, zero trust relationships where you can share data about yourself without revealing the underlying data. So I could say I'm over 21, right? Because my bank tells a company that I'm over 21, but I don't have to show my ID that has my address on it and other personal information. So yeah, I think it hits a whole bunch of privacy problems with what seems like one giant stone, but it's really like a whole host of protocols and is still in development. So it's not exactly like ripe for prime time yet, but it's the one that I'm most excited about.
Yeah, that one is really cool. I love the idea of keeping data as distributed as possible. So I'm a big fan of distributed data setups. And I think the hardest part of that question becomes validation of identity in a non-centralized manner.
Mm-hmm.
And I think therefore that's like one of the key building blocks. Probably my favorite pet is multi-party computation, because that's the cryptography that I had a chance to work on and work with. And I also think I think that in combination with distributed data and self-sovereign identity could create a fundamentally different way that we do data today, and could democratize and make much more privacy friendly the way that individuals control and manage their data, and when and how they contribute to analysis, when and how they contribute to machine learning models, when and how they contribute to data sharing and so forth. And I think that could be really extremely powerful, but obviously getting each of those, to the state where they need to go, where I could say, hey, I actually don't want any data shared from my device anymore. I'd like to keep all the data local, and I'd only ever like to share it in encrypted form. And you are only ever allowed to decrypt computations that I contribute to if you can prove to me that this many participants have taken part, or if you can prove to me that differential privacy noise was added to the tensors at some point in time, or if you can meet these other requirements that I have. And I think that there is a possibility that we get there. And I would love to see it in the time of my career. But all of the pieces and the building blocks we know are there. They just need to be kind of brought, as you say, by a larger amount of companies, and also made more present and more user-friendly for the users who I think would opt into this stuff if they knew it was available, and if it was made present, or, if it was shown to them in a way where they could understand it.
Yeah, I agree. It's one of the things that it gets me excited about privacy, is knowing what is being worked on, what privacy enhancing technologies or privacy techs are creating for the future. So I've gone into some standards. I'm looking at certain specifications. I'm finding that is giving me a renewed sense of hope and optimism for privacy. Whereas most people are looking at the world, they're looking at, feeling powerless about the amount of money that is, taken from them through advertising, or their data without, consent, and, just feeling like they don't have the ability to have control over their own information, and whether or not you can be in control of your own data, or if that's something that's not possible, is not the topic I want to go into. But the feeling of being out of control right now is what makes people super pessimistic and wary of technology and distrustful. And so it's just a weird dichotomy to have most people feeling that way, but then as an expert telling them how I think the future is going to be pretty rosy, in my opinion. There's definitely a disconnect that feels uncomfortable, but, that's where the evangelist in me comes out and starts, trying to paint the picture of the future.
Yeah, exactly. And I think sometimes when I talk, I don't know about when you talk with folks not in the privacy space or in the technology space, they're like, whoa, I didn't even know that was possible. That's so cool. Why can't I do it on my iPhone right now? And it's like, oh, okay. I think there's a growing consumer demand. And as privacy engineers and other privacy technologists who are listening to your show and who are deploying these technologies are doing it, hopefully they're also chatting with the product people and saying, hey, you know what? This is like a perk that we can offer people. This is something that we can advertise and say, hey, look, we're handling data responsibly. And I think it can be truly a win-win in both cases. It also reduces risk and all of these other things. So I think it can be a big business win as long as businesses say, hey, this is something that we really want to do. We want to invest in.
Right. I want to turn to talking about adversarial attacks. This is something that's really interesting to me because, well, my fiance is a hacker and, he works in bug bounty. And so as a result of being together for 8 years, I've learned a lot about that space. And so I find it fascinating. And what I see here is that adversarial attacks to machine learning models could be things like adversarial input, feature and model extraction, certain privacy attacks. And I'd love for you to just unpack what it means in the machine learning space, because it's definitely not the same thing as security per se. Like, you're not going to have a bunch of hackers that you don't know and ask them to submit bugs through a bug bounty platform. And their ability to do black box testing is going to be, I would think, pretty impossible, right? For machine learning, like when you have to have access to the models.
I definitely think more people should be doing that. I mean, some of even what we see with the prompt engineering and the prompt hacking of the GPT-3 based models is pretty extraordinary how quickly, let's say, folks learn clever ways. I mean, it's hacker mindset, learn clever ways to say, can I get it to show me the prompts that it's actually getting? Can I get it to reveal anything about the training data? All of these are active things that are happening. And one of the other things that's happening in the machine learning space is we're starting to ship more models to the edge. So we're shipping models to edge devices, we're shipping models to phones, and we're shipping models to cars. And this means that the model is literally sitting on a piece of hardware that somebody can probably find a USB port for or another port to extract. And then this person has the model. So let's even forget about advanced stealing techniques. You have direct access to the model. And when you have direct access to the model, if you know what you're doing, there's a number of adversarial attacks that you can plan, that you can propose, and that you can also then use the model to reveal information about the training data and so forth. So one of the classic ones is model inversion attacks, where you have a particular target class that you would like to target and have the model reveal to you what it knows about that target class. In the case of, let's say, a facial recognition or a voice recognition or anything biometric related, this is extremely dangerous because the target is the biometric details of that individual. So it's dangerous not only from a security perspective, but also privacy perspective. But then there's other attacks like membership influencer attacks, which try to look and say, was this person or was this example in the model training data set? And those have become more and more advanced with the time. In fact, to the point where there's now more generalized ways you can do membership inference to give you details about the types of people or the types of population that the model saw in the training data. And within all of that, there's also been some really interesting work on model explanations or in any outliers in any of these large language models or other large machine learning models, where the outlier space, so we can think of a multi-dimensional vector space that the model has been trained on, seen, and now essentially has saved in a variety of the ways in the architecture and so forth. And we can use the model itself to try to find sparse regions of decision space and to actually output that information. And that is readily seen and easily hackable, even by people without machine learning knowledge, when we look at things like Stable Diffusion or DALL-E. When you give it a prompt, and if you give it like an obtuse artist name, something that you think maybe it hadn't seen many examples of, or if you go to ChatGPT-3 and you ask who you are, ask the model who you are and see what a response it gives you. You can sometimes find little pockets where you're like, wow, this is an outlier space, and this is directly revealing the training data, because the training data in that particular vector space or tensor space, really the multidimensional, the training data was so sparse that it basically memorized these outliers. And there we not only have security risks, but deep privacy risks.
Wow. So would you suggest then the bug bounty programs, or, I mean, it wouldn't necessarily be disclosure, ethical disclosure, but yeah, do you think that bug bounty programs should include now potential bugs for machine learning? I mean, would you consider these bugs or like an ethics bug?
I mean, I guess it depends what it does, right? I mean, one of the things that OpenAI did when they basically put a reinforcement learning or an agent-based learning method on top of the language model, because at least my guess is the language model itself was a bit too dangerous to just use without any filter. And so the reinforcement learning, of course, that was made, I think as far as I know, it was agent-based reinforcement learning. So it goes out and explores what are potential useful answers to this prompt or useful answers to this. And then they poured tons of money, as far as I've heard, into doing reinforcement learning with these workers who were paid unfair wages, but with these workers to try to make sure that it wouldn't respond in really, really icky ways, like displaying racism or homophobia or sexism and other things like that. Because what we often find with these large models, and you can also see it in the first release of Stable Diffusion, is there was examples of revenge porn, there was examples of executions, there was all of these other examples, because they basically pulled as much image data from the internet that they could. And when we think of attacks on these models, yeah, we can think of adversarial attack, where I want it to give me a certain result and I try to poison the data, or I try to learn enough about the model to elicit that response or hide something in my prompt that gets it to do that. Yes, those are valid security attacks too. But there's also like the massive damage risk and brand risk of companies releasing these models or things based on these models if something comes out and it's like really horrific. Right? I think personally, I would be surprised if it didn't become a thing that you want to be like, hey, send us any bugs you might find that are either huge brand risks or also privacy risks or also security loopholes that we might have missed. And we especially can think of this in the case of something like self-driving cars or other things like this, that it's not going to be feasible probably for these companies to think of every potential scenario. And it's much cooler to have hackers like your partner and so forth to kind of help with that, right? To bring the really knowledgeable hacker mindset to something like machine learning and to figure out, because we only know what we know so far, figure out maybe there's even stuff that we don't know right now that could be attack vectors that we haven't even thought about.
That makes sense. It seems like there might be an opportunity there. Certainly would upskill the external hackers to make them more aware of what they should be looking for, rather than, I guess, train data scientists to be hackers and submit bug bounty programs. But maybe there's an opportunity to overlap there. Who knows?
Yeah, it'd be a cool collaboration.
It
That's for
would.
sure.
I think it would be.
Yeah.
So let's see. You were talking earlier on about consent, and I was hoping we could talk now about maybe LLMs and the lack of consent in creating large learning models.
Yeah. So these large models, it's a bit of a conundrum that we're in. So I come from early NLP days, which means I've actually done quite a lot of work and it's easily found online on web scraping. And I think that we kind of just marched forward as a field being like, okay, we can build better models if we have more data. One way that we get more data is we go scrape it. Let's go scrape more data and then let's train and let's see if we improve. And it wasn't that prominent, I think, at that point in time to think about the privacy aspects because all of it still felt so new, and it didn't feel like we were ever going to be able to build machine learning models that were going to be so powerful, right? That's since changed. Now it's indeed the case that and the field has moved on by amazing research, right? And I'm not somebody that's against further research and development of these, but I am somebody that's deeply aware of some of the both privacy and ethical issues of these massive, massive models. And I think that we have to at some point start asking as an industry, particularly for machine learning and data science folks, but also as a greater field, as anybody that deals with data, including privacy engineers and so forth, like what's really makes sense here? How can we create a more consensual experience for people who want to either be remunerated for their own work? So let's say you're a journalist or you're an artist or you're a writer and you're happy to contribute your work to these models, but if they're used to, let's say, produce more art based on your art, maybe you'd like a few pennies per use, or maybe you'd like to be made aware that some art's being made and you want to approve it, or just give some credit where credit's due. And I think that that's also the case when we look at, let's say, the image generation models and we look at generating faces of people who don't exist. That face existed somewhere. There's pieces of that face, and they've actually been able. There's a really interesting paper called "This Person Probably Does Exist," where they reverse engineered some of the "this person does not exist" examples to the actual celebrity data set that they came from. But I mean, I think the thing is like maybe we now know we can build really powerful performant models. And now maybe it's time to ask, can we build powerful models with privacy? I think the answer is yes. I hope that some of the listeners of your show, they believe the answer is yes too. And I think it's the time for maybe the machine learning community to truly embrace privacy and consent, and maybe even thinking through the whole ways that we collect data and just making them more transparent, more fair, more privacy based, more consent based. I think that would be a really cool next step.
I agree. I think that would be a really cool next step. I wonder if the political will is there from whether it's OpenAI or other companies. It sounds like there's an arms race right now to see who's, chatbot's going to win. And if we asked OpenAI to throw out the training, set that ChatGPT was trained on, would they be willing? I'm thinking definitely no. So, I mean,
yeah, I think you're right there.
Right. So it would they would lose their lead. They would, have to go back to the drawing board, but even if they came to market arguably unethically because they did not include privacy, it's not like you could just add or subtract the box of privacy off of the product, right? It has to be built into the whole design. So what can they do, if anything? What is, I mean, I have to admit, I've even used it when, well, not, maybe it wasn't that, whatever the Lensa app uses. I've used one of the LLMs to train my, photo, and I gave up my photos to be part of the training set, which I didn't care about personally in that moment, so that I can get cartoonish looking pictures done in a certain way of me, which I wanted and I got. But then, after all whole debate in the public sphere about whether or not, it's even ethical to contribute data at all to unethical data models,
Yeah.
right?
Yeah, but I have to just jump in real quick because I think it's such a dangerous slope that we're on if we start blaming the users for the privacy problems or the ethical problems. Like, I absolutely 100% disagree with the idea that, like, well, you're at fault if you're ever on Facebook or something like this. It's like, no, we should have better standards as an industry so that if, folks in my life want to reach out on WhatsApp or whatever it is, it shouldn't be that it's shameful to want to use something cool like the Lensa app or another thing that you want to try out. Absolutely not. I mean, that's totally the wrong way of the power in that relationship. Instead, I think, or what I hope, and I know that from this conversation, what you hope too is, the industry needs to up the ante and say, you know what, like, we can offer you something cool like this and make sure that your data remains more protected and make sure your data won't be saved and stored on our servers unless you click this extra special box. Or that if you're involved in a machine learning training round, that maybe you get access to the model or maybe you get dividends or something. I mean, there's so many possibilities we could think of if we decided, the user is at the center of their data. If we're going to use the user's data, and guess what? We could get so much more data if users actually wanted to give their data, right? So like the scraping the web is like the hard way to do it. If we really wanted to build amazing large language models, we would create ways where people feel comfortable uploading much more text that they're willing to share because they get a copy of the model or because they get to contribute to something that's cool and is going to be used in a way that they find meaningful, right? And I think the conversation has to shift where the blame is never on the user. The responsibility is on the company that's making these and the people involved in producing these models. And they need to own the power that they have in that relationship and say, you know what, I'm going to do a really cool privacy respecting Lensa app. And you heard about it here first.
Awesome. Yeah, I mean that makes sense. I guess I was just thinking more in terms of as an ethicist myself, probably not the best leadership to go and like, oh wait, you're telling me it's trained on other people's data? Let me go give my data to it and then like try it out. But I did. I needed to understand how it worked, and then I just wanted to do it. I kind of convinced myself that was why. But it's kind of like with Facebook, even back when, it had even fewer privacy protections, all the privacy experts were going to Facebook because they had to advise their clients who were using it how it worked, what settings they suggested, things along those lines. So I do agree with you. And I was just saying as an ethicist myself, probably, a little embarrassing to say that I went and I did something that I thought was unethical, right? But here I am doing it on my own show for all of you to hear.
Yeah. I think, machine learning will keep going on. And I think it's cool to see where we can go, and that I hope that researchers in the machine learning and privacy space focus on ways that we can do it better as we move forward.
Agreed, especially ways that we can make it safe. My God, this episode has just like flown by. I honestly, I feel like I could speak to you for hours, but unfortunately we're at the conclusion of our talk. Is there anything you want to plug before we say goodbye?
Nothing top of mind, but if you're curious to learn more, I have a newsletter that's called Probably Private, and I have the book coming out, should be published probably May or June this year, called Practical Data Privacy. And I'm excited to hear responses. Gift it to somebody if you want them to get into privacy engineering, and so far they're just into statistics and math.
Well, thank you so much. I know I'm definitely going to read your book, and I'm going to put links to those resources in the show notes. So, Katharine, thank you so much for joining us today on Shifting Privacy Left to discuss ethical machine learning and PETs.
Thank you.
Until next Tuesday, everyone, when we'll be back with engaging content and another great guest. Thanks for joining us this week on Shifting Privacy Left. Make sure to visit our website, shiftingprivacyleft.com, where you can subscribe to updates so you'll never miss a show. While you're at it, if you found this episode valuable, go ahead and share it with a friend. And if you're an engineer who cares passionately about privacy, check out Bravado, the developer-friendly privacy platform and sponsor of this show. To learn more, go to bravado.ai. Be sure to tune in next Tuesday for a new episode. Bye for now.